So you'll see that that puts that USB hole in place, and inside your kit with your power supply is a USB cable that fits that hole. Okay, so with that in there, now what we need to do is go ahead and put in our little power cable. So I went ahead and attached a section of wire on these power cables. I thought it would be easier for everybody to install them, so I just went ahead and soldered them up and got them ready. So what we're going to do is we're going to take this, you're going to unscrew the nut from the body, and you're going to slip it through the hole. Now, this hole is not a perfect fit. My sample power plug and my production power plugs I got were two different things, and by the time I got the production plugs, the holes were already cut. So it's a little looser fit than I would like, but I tend to orient it with the plug hole. It's offset a little bit facing down. And then what we'll do is we'll go ahead and put the nut back on once we've got that in place. Kind of snug that up. And then I'll kind of, again, get this where I like it and kind of push down on it with my hand. And then we'll use a pair of whatever tool you have necessary that can handle that big of a nut. And we'll just kind of snug it down. Again, working with wood, don't have to get crazy. There you go. Power plug mounted in. Now, since we're here and it's a little easier to see why this thing is open, what you can go ahead and do is plug this wire into this green power block. That block right there is where you feed the power into the servo board from the power plug. So what you want to do is make sure that you check and see there's a plus and a minus on the board, and so you want to make sure that you get the red wire on the plus and the black wire on the minus. And in this orientation, the red wire is facing to the top. So I'm gonna okay, so you want to get those into there real well. Make sure you don't have any extra little wires hanging out that can short across. And you're going to tighten those lugs down nicely, making sure, like I said, make sure that you don't get any little stray wires coming out and jumping over to the other port, shorting that out. And so what I'm going to do is, since I only have this little thing, I will go ahead and just use it along with my pair of pliers to give these just a little bit of extra tightening there. Okay. So there you go. That connects our power plug to our circuit board. Something that I will talk about real quick on the electronics kits. On these servo boards, they have an on and off switch, and that on and off switch turns this power coming in through this power plug is strictly the power fed to the servos. It's not the power that runs the electronics on the board. That power comes from the USB plug. So you have an on and off switch here which will turn on and off the servo motors, but yet still let you be able to talk to the board. So for right now, we're actually going to leave that in the off position. I like to do that so that I can make sure that I am communicating with the board before I move the servos. And the way that can be done is there's a series of LED lights on this board, and they blink. A red and a blue light will blink when it's receiving signals from the computer. So by leaving the servos off and watching for those red and blue blinking lights, I can make sure that my software is configured correctly to know that I'm talking to the board before I start moving the servos. So I leave that switch in the off position. Okay, so that's all put together as much as we can. So now all we got to do is drop on the top. Now again, the board is coming out the back of the base, so we want to make sure that this slot goes to that same side as the back. So it goes on like this. Now these you might have to loosen your box, you might not. Could just drop on there, just kind of tweak it around. But you'll see that that top will just press right down on there. And so our next step will be to insert these 6 nuts. So I'll go ahead and do that right now. Okay, so we've completely assembled this box, and I've gone back and I've tightened all of my screws all the way around because I left them kind of loose while I assembled everything. And so what you'll find is we have the servo wire underneath that is the arm twist. That gets plugged into the servo board. I don't have my paper with me right now as far as where they go, so I'm not going to do that. So please reference the document as to what channel you would plug it into on the parallax board if you're using my type of stuff. Obviously, if you're using your own electronics, you plug these channels into whatever you would like. And so the final thing we have to do here is we have to go ahead and attach the arm to the base. So here is our arm. And so what we're going to do is we're going to go ahead and take our wires. Now we got to take all these 8 wires feeding out here, and we want to feed them down through the slot in the base. So what I tend to do is just kind of stuff all the tips down through first with the arm sitting next to it. Okay. And then I'll kind of tip the base up and reach through and kind of gently finesse all the servo wires through until everything is ready to go. Oh, I got one over there that's giving me trouble. There it is. Okay, so now, what you're going to do is you will see this servo horn is going to line up on that servo. Now, we're going to use the same process we did before with rotating it left and right to its extents to make sure that we're on the horn center. So I don't know where that servo is, so I'm just going to kind of set it on there at first and get it to grab a little, and then I'm going to rotate. So that goes about 90 degrees there and about 90 degrees there. So it looks like that servo was pretty well centered. So we're getting about where we want to be. We're getting full pointing one direction. You rotate it around, getting full pointing the other direction. That to me is good enough. I wouldn't fight that too much more because I can tune where it sits with my software a little later. So now that we're on there, what we can do is kind of watch your wires there. You don't want to try to smush them too much. I'm going to go ahead and just kind of give this arm a little push to kind of get that servo horn to seat. And so now where we get the fun of tightening that servo down in the middle. Now you can see I've gone ahead, and because we put that piece of tape in there and that servo horn to begin with, it's already down in the hole ready to go. If you didn't do that, you've got to kind of, what I usually would do is set the servo horn, the screw on the screwdriver and flip the arm upside down and then feed it up through until you can get it in the hole. And it is not easy. So what I'll do now is I'll take my screwdriver and I'll just pop through that tape, pop a hole in that tape and find my screw. And once that happens, I can start tightening down that center screw. Now again, this is a metal screw into plastic servo spline. Be careful. It's a tough one to feel. I have actually stripped some out. So I would rather you be a little more careful and leave it loose and have to tighten it up a little later than to have you over tighten that screw and strip it out. Use a small screwdriver if you can, and you'll feel when it gets to the point where it stops, and that's tight. And so what that does is gives us our rotation. Now, with that mounted, the last thing mechanically that we have to do is now we're going to go ahead and fit the skin. And so what I say by that is I just set the arm down flat on the table, get it all centered up, and I just kind of push the skin down against the wood base. And what that's doing is it's stopping the arm from having a lot of ability to slop around. If we remove all that gap to where this arm skin is riding against the wood, it creates kind of a bearing surface to hold the arm more stable. It's not going to hurt anything. It'll leave a little mark on the wood, but nothing that's noticeable while the arm is assembled. So again, I push it down, and then what I'll tend to do is I'll start in the back. Make sure that you center up this skin against the back middle of the arm, and then I'll tighten these upper screws first, and then, you know, again, keeping pressure to kind of hold it downward. I'll tighten these two lower, and then I'll work my way around. Come to this side, I'm going to push down on the skin, making sure it's all the way down. Tighten that one, tighten that one, and tighten that one. And then rotate it. Now, obviously, you don't want it, if there's something could be off somewhere, you don't want this dragging heavily. If you can feel a drag because the skin is hitting really hard against the wood, something's not right. It should just be against it, but not dragging on it. But what it does is it helps stabilize the arm. Okay. So mechanically, we're finished. So all that would be left to assemble this arm is to plug in all of your servo wires. So what I like to do, it's kind of hard because this arm sticks out so far, and maybe I'll post some pictures of this. Basically what I like to do is, now is when we would take our servos, we'd plug in our servo tester, something similar to this guy. I don't have it powered up right now, but I would plug it in and I'd move the servo and I'd see what actuation happens on the arm, and then I would label the servo and go through and do that with all 9 servo wires, and then take the sheet that I will send out and use each movement to pair it with the appropriate pins on the electronics board. Now that can get a little bit crowded in there as you go. If you want to drop the board so that it's out and you can put those on and then bolt it back in, you can, but those lower screws are really tough to get to when it's all assembled together. So I just kind of wing it from here. Again, reference the board instructions. Parallax has really good documentation on the board. Nothing comes with them, so you'll need to pull that off the internet. But with the Parallax documentation and my servo listing, you'll be able to plug all these in and get it working with the software that I'm using. And then once these are all plugged in, I tend to kind of pull them together, wrap them up, and put a little zip tie anchor stuck to the inside of the box that I can zip tie them to keep them from hanging out. But you need to make sure that you leave enough slack in the wires to allow the arm to rotate the full 180. And also in your software, I like to limit this 180 degree turn to maybe 160 degrees so that I'm not smashing those wires into that wood every time they come around, because you'll just end up wearing them out and breaking them, and you really don't need the full rotation. So I tend to limit that rotation down a little bit as to avoid breaking the wires. So I'm going to stuff these all up in here, and I'm going to set this guy up like it goes. And that, my friends, is how to build Roy's arm. Again, I want to thank all of my backers who helped bring this project to completion. It's been a lot of work. I apologize if it's taken a little longer than we all had hoped, but we are finally to the point where I think everything is there. You guys can build and enjoy some interesting robotics. So again, thank you very much, and until we meet again on the next part of Roy.